Hi, so hello everyone. Today I'll be talking about my subject data warehouse and data mining, in which we have done a project railway reservation system which we have built using a star schema. So let's talk about the project. We have designed and implemented a data warehouse for a model railway reservation system using a star schema of dimensional model. The goal is to create a system that efficiently stores and analyzes railway booking data, enabling business insights such as top revenue generating routes, station traffic, and class-wise ticket sales. The main objectives of the project was the purpose was to create a data warehouse for managing railway reservations, analyzing passenger traffic, route popularity, and overall performance. Objective was to implement a dimensional model using a star schema for easy analysis and query optimization, and implement it using Oracle or MySQL. We have used MySQL for it. The field schemas we have used are passenger. This will contain all the information about passenger, like passenger ID, station name, age, email, phone number. Train, like this table holds information about the trains that run on the routes, like train ID, train name, train type, and total seats. Another field schema is station. This holds information about all the stations in the railway network: station ID, station name, city. Class schema. Class contains details of different travel classes such as AC, sleeper, and the prices. More field schemas are like dates, route, and tickets. Tickets include ticket ID, passenger ID, train ID, date ID, route ID, class ID, quantity, total amount. Now the stations table. So we have created this station. As you can see, this is the code like create table station. This is a SQL code, and we have created a station. We have created a SQL database in which we have created a stations table. In the same way, we have created a train table which contains train ID, train name, train type, and total seats. In the passenger table, we have created passenger ID, passenger name, which is a data types are int varchar, and description is like first name of the passenger, last name of the passenger, age, email, and phone number. Then there's the dates table. In the dates table, we have created date ID, date, day, month, year, day of the week. Route table. This holds information about the train that run on the route. Route ID, start station, like where does the train start from and where does it end, and the distance it covers. And there's a class table, class in a different classes such as AC, sleeper, and the price. Class ID, class name, and price. The same way we have done it with ticket table. Now we have used a star schema for it. A star schema is a database structure used in data warehousing. It consists of a central fact table surrounded by multiple tables. The fact table stores measurable quantitative data, while dimensional table stores descriptive data to describe the facts. For example, in the quantitative data, you'll like facts, like you store facts in it. In the dimensional table, it stores descriptive data, the attributes for it. So, like for example, the ticket table is the central table where all the booking data is stored, and it references multiple dimensional tables that provide context to the ticket sales, like passengers, how like which passenger bought which ticket, for which train, and that train is going on which route, and it will be going on which station, and what are the dates for it, and what is like how many classes are there, like how many AC, third AC, second AC, first AC, like that. The benefit of a star schema is it's simplified queries. If you want to find all tickets booked by a passenger, you can easily query the passenger and ticket tables. Benefit. Benefit of a star schema is the star schema is used in railway system to offer several benefits. Like first of all is simplified queries. Example, if you want to find all tickets booked by a passenger, you can easily query the passenger and ticket tables. The benefit is the structure allows you to quickly join passenger dimension with the ticket fact table without complex joins. Another benefit is faster query performance. Calculating total revenue by route can be done quickly by querying the ticket fact and route dimension tables. Benefit, fewer joins between, like it will be we don't need to make complex joins. We don't need to perform complex joins to find the relevant information. Like this is the star schema of our railway system. As you can see, the ticket is the main fact table, and it is connected by many different tables like passenger, dates, routes, stations, class, and train. Now, business query services, like we have done some business queries also. Okay, so now I'll be talking about the business query services. Like we created the whole database. Now we'll be performing some queries on. So the first query is total revenue generated per train. This query retrieves the total revenue generated by each train. Like for example, we wrote the code select train name and we sum the total revenue as total revenue. And we take it from the train dimension table, we join it with train ID, we join two tables and train name table and train dimension table. Now it gives us a train name and it also gives us the total revenue from that train. As you can see, there's a table right here. And next query is the most booked train routes. This query retrieves the train routes with the highest number of bookings, like which train has got the highest bookings. So what we did was the it tells us the train route, so we don't need to know the location now. So we what we did was we took this ID of the start station and the end station. Like as you can see, we wrote the code for it. We used join, group by, and order by. And now you can see as in the results, like from start station like 4 to 6, there are 4 bookings. So it's like pretty high. Same is with the start station ID from 8 to 6. And for 4 to 10 it's 3. So like this we can find out most booked train routes, and this is how we performed this query. So now the next query is average ticket price by class. This query calculates the average ticket price for each class. Like each class is AC first class, 2 tier, 3 tier, sleeper, general, chair car, executive class, second sitting, first class, and third AC economy. Now we wrote the code in SQL, MySQL, and we got the table and we got the average price. So the next is top passengers by revenue contribution. This query identifies the top passengers based on the total revenue generated through their bookings. For us, this is a small data. We use a small database, but in real life, the data is pretty big. So we use a smaller database, and from that database, we can find that Vikram Singh is one of the highest guys who has traveled through train, and he has a total revenue of 10,500 rupees. This is another query. So to conclude, I just want to say that railway reservation system using star schema. So this is how we presented. We created the field schemas used. We created all the tables one by one. Then now we know star schema is database structure used in data warehousing. It basically it's in form of a star. Like there's a middle table, the fact table that stores the measurable quantitative data, and the dimension tables around it store the descriptive data. We already told the benefits like simplified and faster query performance. This is the star schema that we use. So this is we can tell how we have created the database. So I just want to say thank you. Huh. Yeah. So now to conclude, so this is how we created our railway reservation system using a star schema. And thank you for watching.